Hello, everyone. I'm going to share my screen and get started. I'm Jepson Taylor, and today I'm going to be talking to you about generative intelligence, keeping up with the pace of applied intelligence in the near term. I am Dataiku's Chief AI Strategist, and one of the things I'd like to do before just jumping into AI is I'd like to start with intelligence. I think before we can talk about artificial intelligence, let's just discuss intelligence because I think it's a good foundation. So there's different definitions. The definition that I like the most is intelligence is defined as the ability to acquire knowledge through experience and apply that to future decisions. And I'm going to have a little bit of fun. We're going to go through two animals in the animal kingdom. I'm going to ask you if they're intelligent, and then we're going to settle on humans. So take this caterpillar, for instance. Is this intelligent? So according to our previous definition, is it going to learn? If I do something today, if I poke it in the eye, is it going to pull away tomorrow? It's a terrible experiment, but it's something that we could test. This might be a simple enough life form. We might be able to show that it has a difficult time anticipating something like that, but maybe it can learn. Take something like a cat, something that's more advanced. If I poke this cat in the eye, it will avoid me not only for tomorrow, but it might avoid me for the rest of its life. But a key difference here, when you think of cats versus humans, is I could poke every cat in the eye at least once. Humans are unique. No other animal comes close to us when it comes to our ability to transfer experience. So a negative experience, and if we keep the analogy or the story going, if I poke a human in the eye, and if I do that frequently, not only will all the humans in society know that and avoid me, but even if I left and came back hundreds or thousands of years in the future, they might still remember that through stories. And so our experience is compounding. And for those of you that are listening that have medical backgrounds, there was one point in my life I took the MCAT. I was studying to go to medical school. My dad's a physician. I the amount of material that I had to learn in chemical engineering to try to achieve a certain level of knowledge that many of you have is pretty overwhelming. But if we take a step back and think about it, none of us can take credit for the amount of knowledge that we have. We have to thank all the people around us. We have to thank our teachers, our peers, our mentors. We have to thank the people that came before us that had those lessons, that did that initial research. If you think about all the mistakes that were made in what is considered Western medicine to get to where we are now, it's pretty significant. So bloodletting used to be considered best in class. If you think about holistic or alternative medicines versus Western medicine, things like bloodletting and some of the ideas and cures that they had to prevent scurvy were pretty nonsensical and silly, but it was all they knew at the time. So, so going back to this concept of intelligence, uh, two questions I'd like to ask the audience are, if you think about your own intelligence and where you are now compared to when you were younger, when you were in school, how much smarter are you today? And it's pretty hard to quantify. Are you twice as smart, 100 times smarter? It feels nearly infinite. But one of the important things to think about is time is not a guarantee of increased intelligence. Neither is experience. Did you know that experience can bias us? We have unconscious bias. We're creatures of habit. The longer you work in a process, the longer you're stuck in a process, the less likely you are to innovate that process. You've probably worked for organizations where there is a culture or an attitude of this is how we've always done it. And I'm hoping to show you as we go through this talk track that this is all changing drastically, especially this year, and it's only going to change faster and faster going forward. So the nice thing about having the foundation of intelligence is it now sets the table for AI, because what's the intermediate between human intelligence and AI? Well, the intermediate is data. So just like you have life experience, opportunities, challenges that you've been able to overcome that have made you wiser to make bigger, more complicated decisions, you also have your data experience that is flowing through a business, through an organization, through a hospital. And unfortunately, there are fundamental problems that every organization deals with. And so one of those key problems is processes are stale. So if I came in and audited your systems and said, when's the last time you changed this process? For a lot of companies and a lot of hospitals and organizations, we might find out that it hasn't been changed for 5 years, 10 years, or never. It's never changed. We've never changed this process. The second issue we run into is knowledge workers leave. So if you think about yourself when you're junior, you come into a role, initially you feel insecure, you kind of need to shadow someone and come up through the ranks, but then over time, you become the principled, gray-haired, gray-beard individual in the room. But then if you leave, that knowledge can never be completely transferred. And then the final issue that organizations all deal with, or the final problem that a lot of organizations deal with, is they do not leverage their data for better experience. So I'm going to tell a few healthcare stories that are related to this. So during COVID, I was tasked with calling hospital networks to get access to patient level data. And I remember having a very frustrating conversation with someone on the phone where they were a senior health informationist. They had access to patient level data. And they told me over the phone that not enough people have died to understand the disease. And it's very upsetting to hear that because I know where they're going. And I said, what do you mean? And they said, we've only had 6 people die in our hospital network. And so this is a huge tragedy for Americans or for anyone who's dealing with a healthcare data set that has not been centralized and anonymized. So the thousands of deaths in New York were completely meaningless for building models and understanding the disease for hospital networks that weren't sharing data. The other issue that is more personal is I have relatives and family members that have different illnesses, and my wife has chronic kidney disease. So she has gone 17, 18, 19 years now where Western medicine has failed to diagnose her. She's had a kidney biopsy. They looked at all the blood work, all the urine analysis, and they don't know why she permanently lost 20% of her kidney function every time she had a child. Fortunately, she's not having more kids and the kidney function is not dropping, but this is an example where whatever issue she's having, whatever problem is causing this, it will most likely not be named after her. And there are many, many people that are having this issue, but that data is not leveraged for better decisions. But if you can make the data centralized, and if you can respect privacy, and if you can have a proper data lake that's ready to go to work, where you're not having to do heroics to get from data to value, that now opens up the conversation for AI. And I've been in this industry for a long time. I didn't really go do a more formal or deeper introduction, but I've worked in semiconductor for 5 years. I've worked as a quant at a hedge fund. I was the chief data scientist at an HR tech company, predicting video interview outcome, and I built and sold a deep learning company. So I've been in this space for a long time through different industries, but I've seen this industry grow up. And one of the things that's been happening as this industry grows up is we're able to get into more higher consequence decisions that require more and more trust. Decisions that can make or break a company, decisions that could impact a life for good or bad. We're finally playing at that level where we can do that responsibly. The other thing that's been happening too is our ability to consume different data types has also increased. So before it was just structured data. So think of data that is in a database, and that then evolved into unstructured data, text, images, audio, video. Can turn off a notification really quick. Apologize for that. So by bringing AI into our data and by allowing us to collaborate, this last point is very important. AI is not successful in a silo. It is not successful as a black box effort. It has to collaborate with the domain experts. The domain experts will always have something that AI does not. It will edge cases, intuition, domain knowledge, but also the safeties that we want in healthcare. You don't want an AI physician that is writing prescriptions or doing things that don't have a human in the loop, because AI can do things that are unexpected sometimes for various reasons. So I'm going to show you a few examples where I want to contrast where we are with AI and how far we've come. So this was a marketing piece that I worked on a project 7 or 8 years ago teaching AI to play Call of Duty on the Xbox. It had a very powerful server from Intel, 12 terabytes RAM, and I was using reinforced learning to do this. And for the marketing piece, I sat down at a coffee shop and sketched this out on a napkin. And the question for the audience, and I chuckle a little bit if this is outside your wheelhouse, your normal wheelhouse, but guess what was the cost and what was the timeline? So I had a sketch on a napkin, I handed it to a designer, and then they came back a certain amount, weeks later, and I paid them a number for this. So if you have the time and the number in your head, a lot of people guess $5,000, 2 weeks. It was $1,000 in 1 week. This is a great designer that I work with. And now for the next image, some of you know where I'm going with this. So this is another one that I created. Look at the detail. Look at the depth of field. Look at the reflection on the shoulder. This, and there's also some optical effects that are happening here, some heat effects as well. This was made with Midjourney, so it was done for pennies and in a few minutes. And I'm using GPT-4 to help me write these detailed descriptions or prompts that go into Midjourney. If this was done before, I don't know if I'd be able to deliver a piece of this quality for less than $50,000 and sooner than 2 months because of the complexity that is happening here. This is a much more complicated piece. And so the world is changing. And I'm going to walk you through some Midjourneys. And the thing I want you to take away in these Midjourneys is the amount of creative comprehension that demonstrates that it's really understanding the underlying data. And the analogy is also true in healthcare data. So when it comes to EKG heartbeat waveforms, medical images, patient level records, the amount of comprehension that we're at now is pretty remarkable. So this image here, the input was I gave GPT-4 the article about Worm GPT. That's that large language model that showed up on the dark web to do malicious activity. And I asked it after it read that article, I asked it to come up with an image that describes the creature, if such a thing existed, that is Worm GPT. And it came up with this. And this is a profound image, especially for AI to come up with. Here's another one that's a little bit more fun. This is me. I enjoy Midjourney, just playing around, coming up with new concepts, testing them, a little less depressing. Here's another. The amount of detail is remarkable. The other thing that might impact some of you in the home is it can do much more than just coming up with pretty images. You can actually ask it to design acoustic wall paneling. So if you have a grand piano in a room and you want to break up the flat walls, not only can it produce this design, it can also go take it into a depth map, and that would then go downstream into a CAD system. So you can imagine something on the left actually being designed by AI, approved by you, or even optimized, and then sent through CAD and sent into a fabrication provider and then shipped to your home and installed. Something that would be very labor intensive before can now be done much sooner. I'm going to show you a few more examples of comprehension, and then I'm going to get into a new technology category. So for this example, I asked GPT-4 and Midjourney to describe Microsoft as a creature. Let me show you another one, SpaceX. In the through line going through this, the thing I really want you to appreciate is the level of comprehension. So the fact that it's designing all aspects of this alien type insect to represent the company SpaceX it's jaw-dropping that it has that level of comprehension. Here's McDonald's. The other thing to think about too is there aren't just a few variations of these. I have an unlimited number of creatures that represent McDonald's, and if I want to try different variations, I love the French fries in the hair. It's everything about this image is coming from the data. Snowflake, if you're familiar with Snowflake, they're a lakehouse company. They compete with Databricks and IceWolf. So the theme that we started with the images, what's the time and the timeline to deliver the artwork? There's also something that's starting to happen now in the algorithm space. So it's not that important that you understand all of the code that you're looking at. But if you were asked to estimate what's the time and the cost to deliver the code that you see, the cost is there is no price tag before GPT-4 showed up. So what you're seeing is this is a synthetic algorithm that's been written by GPT-4. So it's a generative algorithm and it's beating human benchmarks. So this is a complicated plot, but it's an important plot to understand. So I'm going to try to walk you through it. Every bar is an algorithm. Every red bar is an algorithm that was invented by a human. And these are algorithms that are actively used in healthcare, in biopharmaceuticals, and oil and gas. These are optimizers. And they're used to optimize expensive processes or potentially systems. There's a lot of sensors within an MRI machine, other things like that, that are optimized for signal to noise ratio and to improve the quality of the data that they're able to capture. So if every bar that is red is an algorithm that's written by humans, every bar that is not red is a synthetic algorithm that was created by GPT-4. GPT-4 is powerful enough that it can create synthetic algorithms. The shorter the bar, the more competitive the algorithm is. And so what that means is we're moving into a new era where I believe in the next 3 years, every algorithm that matters will be completely rewritten by AI. And this would also be true for healthcare. So if you think about algorithms that process an EKG signal like heart rate variability, uh, things like that, they will all be replaced very, very quickly in the next 3 years because there will be they'll be faster, more performant, higher accuracies, more trusted, more reliable, et cetera. So the problem we have with generative AI is it doesn't innovate, it just generates. And some of those generations can be hallucinations. It can actually produce garbage. As we roll into this next category called generative algorithms, we are able to innovate. We're able to drive to a goal. So now the goal is producing an algorithm, an app, or even an operating system that achieves the goal that is defined by the human user. This is another way to visualize it that I like. So you have artificial intelligence. Within that, you have the subset machine learning, deep learning, generative AI. And then with generative algorithms, that is really the final frontier. There's not anything else. Because generative algorithms, that is the category that allows for self-improvement. So everything under the hood is all on the table for self-improvement. And the reason I have a dot for that final circle is that's the singularity. So you're essentially chasing the infinite as we enter this world of generative algorithms. Can we place more algorithms, more algorithms, more algorithms? Can we be more efficient? Can we bring on quantum computers? There's not really another big AI breakthrough that's needed. Something that I find interesting, I hope this gets people's attention. I have a 13-year-old daughter. She's interested in making money with GPT-4, and she was realizing that there is an intelligence arbitrage opportunity on Fiverr. So you have a lot of people that are asking for resume coaching. They're asking for code, copyright. A lot of the jobs and tasks that they're asking for, generative AI can actually fulfill. And so it's a wild world to live in to think that a 13-year-old kid could potentially begin automating a lot of these Fiverr requests away when people that were there before didn't realize that OpenAI was available to do many of these things. And the two slides I'm going to end with, I was talking to someone a couple days ago, and my Uber driver, and he was asking if all of this is a good thing for society to have AI this level of capability coming online. And I thought this was a great thing because if you think about what you do for work, for many of us, we are overqualified for the work we're going to do tomorrow. Think about a surgeon that's doing rounds, checking on patients post-op in the ICU. A lot of those patients they don't need their time and attention. A nurse can have good bedside manner. They don't need the cardiothoracic surgeon to walk in on on them if their data shows otherwise. There are other people that need all the attention. And so what you're going to see in the future is you're going to have experts and physicians and clinicians that are focusing a lot more attention on the people that need it. And then the other thing that's going to happen, and I'm getting ahead of myself, so the image you're looking at, this is a giraffe in the zoo, and this is us. We are the giraffe in the zoo. There are brief moments in our career where we're able to work on things where we are underqualified. We have to learn, we have to collaborate, we have to work with a team, we have to do research and innovation. And those moments they can define a career, they can give us purpose. With the future generation, they will be able to do that every day. Definitely every week, if not every day. If they choose to, they can work on impossible problems with smart people. They can be taught knowledge much faster than we were able to in a way that is also much more engaging. And because of that, you are going to see healthcare begin to transform when it comes to leveraging more data for better decisions, augmenting processes better, bringing more sensors online, because AI today has no issues with sensors. We are not designed to assess an EKG signal very well at all. But an AI system can do that much better than we can, because it can monitor every heartbeat over long periods of time at resolutions we can't see, and it can comprehend what this means. The other important thing in healthcare that we desperately need, and we are not bottlenecked with this at all from a technology perspective, it's allowing for search. So if I have a national or ideally global patient level lakehouse where all the data has been anonymized, but it's in a format that is usable. I can build machine learning models to predict disease outcome, but more importantly, I can do search. So now let's imagine a scenario that is all too common. Going back to my spouse, if they go into a clinician or if they meet with a physician, and if they are undiagnosed, or this happens all the time, you can't figure out what's wrong with someone. If there is a centralized vectorized database, any physician can go there, and with that patient level record that's been vectorized and encoded, they can stack rank the millions or potentially billions of patients that are the most similar to their patient. And this doesn't mean they are violating HIPAA. It doesn't mean that they're violating data privacy. They don't even know who these patients are, but they do know where they are. They know which hospital networks they're a part of. They know which physicians worked on them. And so now you can have a process where if I'm a physician with a patient that has an unknown illness, I can reach out to 5 different hospitals, similar patients. I can talk to those physicians, potentially collaborate and unmask them to understand what was the outcome. And so the 1 in a million disease that is celebrated today with the human expert, that will become the 1 in 10 million, the 1 in 100 million, the 1 in a billion, where we can quickly find it. And the tragedies of disasters like the Vioxx disasters causing over 20,000 heart attacks in the wild, that will not happen. And so that it's a very exciting future that we can look forward to. The other point I'll leave you all with is, as we refine and optimize these leveraging data with better AI and algorithms in the healthcare space, that will allow us to escape the hospital. So the best type of healthcare is preventative, where you can, I'd much rather anticipate that I'm going to have a heart attack than have to react to it when I'm out with my family. And so you're going to see a lot of these algorithms coming into the home, coming into wearables, where we can really get ahead of our healthcare needs. Well, thank you, everyone. If there's any questions that have come up during this presentation, I do my best to be approachable. You can reach me at jepson.taylor@dataiku. You can also connect with me on LinkedIn. And I am a resource to all of you when it comes to thinking about AI in taking on some of these bigger healthcare initiatives. And I thank you for your time, and I hope you enjoy the rest of your conference.